Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, how are you all? I hope you all are fine. Dear students, I am your physics teacher, Nafisa here, and I welcome you all in your third physics lecture. I hope the previous lectures are useful and fruitful for you, and you all have completed your written tasks, and most probably you have submitted your tasks to your teachers as well. Dear students, today's topic is also a very interesting topic, and this is going to be your third topic. Before going to discuss the detail of the topic, let me give you the content of the topic. So, today we are going to discuss number one, water pressure. This is on page number 102. After that, we are having a very short activity regarding with this topic, and at the end, we are going to discuss hydrostatic pressure. Students, before going to discuss water pressure, let me share a very simple and interesting example with you. We all know that the solid objects are having the tendency that whenever they are placed on the surfaces, like you can take an example of a book. When a book is placed on a table, it exerts pressure. Now, the question comes into your mind that whether the pressure exerted by the book is in which form. We all know that the weight of the book is actually the force which it exerts on the surface, and that actually develops a pressure. So solid things are having the tendency to exert the pressure. Now there comes a question that whether the water also exerts the pressure, yes or no? Yes, water exerts the pressure as well. Now I am going to first define what the water pressure is, and then after that I will explain in detail. Water pressure. We all know that whenever the water kept in a container, or let's suppose in a certain place water is there, it will exert a pressure. Dear students, we also know that the definition of pressure is force per unit area. On a certain place, the force exerted by in a specific area is known as pressure. So water pressure is the amount of force per unit area that water exerts, say on the container, it's or in a submerged object. Let me first explain the first point, and then we will go to the last point. So water pressure means that water exerts the pressure if a water is in a container. Container means an object in which the water is placed. So water also having the tendency that it exerts the pressure in a specific container. Secondly, there is one more interesting thing, that if there is an object which is dipped or sink into the water also having the tendency to exert the pressure on that specific object as well. So water pressure is actually the pressure which is exerted by the water on a specific area. Okay. Now there comes a next point which is also very important, that whenever the water pressure is there, then what are the characteristics of water pressure? Okay. So point number one, this is the first characteristic. Okay. Greater the water pressure, greater will be the speed of water coming out from the tap. Okay. Now let me explain this point. As we all know that, let's suppose if we are living in a certain place and we are opening the tap, the water is coming in the tap with a very high speed. We mostly say that pressure of the water today it's very high. As we don't have an instrument in our hand, we have no measuring ability at the moment right now in our hand. How we are supposed to say that today the speed of water is this, water pressure is this? What is the main thing why we are saying this? Yes, yes. So actually the water which is coming from the tap with the high speed is the point through which we can say that water pressure is very high. Okay. Now, there is one more thing, that water pressure also depends on the water height. If a water is, let's suppose, at a certain height, then inside the water, if it's a container, It's a body in which the water is kept. Then inside the container, the water is having a very high pressure if the water is located at a certain height. Before going to proceed further, let me give a very simple and interesting example from your daily life. We all are having this thing in our mind, we all are having this thing in our daily observation, that the water tanks which we are having in our homes are mostly kept at the highest roof of the building. Suppose you are living in a building where there are 5 floors and you are living at the ground floor. Now you all know that where we are going to put the water tank. Listen it again. Suppose you are living on the ground floor, okay, and the building in which you are living, you are having 5 floors. Now your water tank must be at which floor? First floor, second, third, fourth, or fifth? Yes, yes, it must be on the highest roof of the building. Now what is the reason behind this? The reason is this one. If a water is kept at a height, there must be a very high pressure water is there. Then inside the container, the water which is there, it must have a very high pressure. We all know that the people who are living in the area, like again, I am quoting my previous example, in a building where there are 5 floors, the people who are living at the ground floor, they are having more water pressure as compared to the people who are living at the 5th floor. Now there comes a question that how the people in the ground floor and how the people at the 5th floor are able to say that water pressure at this floor is more. Simply by this point, the water which is coming in the tap, if it is coming with a high speed, that it simply means that water pressure is more at that specific point. So people who are living at the ground floors, they experience more water pressure as the water which is coming through the tap is coming with a very high speed. On the other hand, the people who are living, again I'm using my previous example, at the 5th floor, the water which is coming through tap is not of the same speed as of the ground floors. Okay, I hope this simple example will help to understand the water pressure, that what exactly the water pressure is and how it actually increases. Okay, now dear students, there is one more thing which is also very important, that characteristics of water pressure basically cater two things. One, the speed of water more means more pressure. Secondly, if water is kept at a height, okay, then water pressure is more. Okay, now let's move on. We are having a very interesting activity regarding with this topic. The topic is dependence of water pressure on depth of water. This is our activity number 7.4 and it is on page number, as I have already discussed, it is on page number 102. For the reference, you can open up your books. That will help to understand the topic and relate the topic with this one, okay, more easily. So for this activity, we need a material required. One, we need a 1.5 liter plastic bottle. Secondly, we need an iron nail. Third, we need an insulation tape. And last, we need a meter rod. Okay, these are a few things which are required by this activity. Now I'm going to discuss the procedure, but before that, let me tell you a thing which is very interesting, that there are two diagrams, as you can see there. Yes, now this is the first diagram initially when we are preparing our operators for the experiment or the activity, and this is actually the final one. Okay, so let's proceed. First, point number one is here. Okay, now for this we need a bottle, which is actually a plastic bottle, and after taking the bottle we need to punch 3 holes at different height with the help of the iron nail. Now that iron nail is used to make holes. The point, which is actually the main point or the key point, is that the holes must not be placed at a single row. Okay, there should be a difference of height, like point number 1, point number 2, point number 3. Okay, Point number 2, now close these holes by placing an insulation tape over it like this. Secondly, you have to paste the insulation tape on these holes. Clear? Now point number 3 is you have to fill the water with the bottle with the water. Fill the bottle with the water, and after that remove the insulation tape. As you remove the insulation tape, you will observe that water is coming out. Actually, the streams are coming out from the bottle. Actually, point number 1, point number 2, or point number 3. You can say it hole number 1, 2, and 3. Okay. For your convenience, you just name the holes like 1, 2, 3 because it will help to actually differentiate between the holes. Okay. As long as you remove the tape, you have observed that water is just start ejecting from the holes. Please, at point number this, remove the tape and observe the ejection of water out of 3 holes. Now, note the distance of the streams of water coming out of the various holes from the bottle. Okay, now dear students, the observation for this point is not given in your book, so I'm going to explain this point. Okay, as we can see that the lowest stream, actually this one, who was named as hole number 1, it covers the distance which is very far as compared to the stream number 2 or the hole number 2. Similarly, hole number 3 covers the least distance. Now we are having a scale here. Let's suppose we just let it be like, suppose 5, okay, 10 and 15. So we have observed from this that the lowest hole, or the hole which is actually at the depth, it covers more distance. Why is it so? It is very simple. We can say that the lowest hole having a more pressure of water at this point. So water stream cover the longest distance as compared to the hole number 1, which is at height, and at this point the water pressure is very less. Okay, now there is one more point. Note the angle which each stream of water makes with the surface of the vessel as it emerges out of the hole. Now again, we are having 3 streams which are ejecting from 3 holes. Now clearly have a look at this point. Also the angle at this point, angle at this point, and this point is different, but we are talking about the point when it is ejecting from the bottle. Okay, it is actually very near to this point. Now just have a very close look here. The stream which is actually ejecting from the bottle, it makes angle of 90 at this point. Angle of 90, angle of 90. So the observation at this point is also not given in your book, and it is that each stream, whether coming from the hole 1, 2, or 3, it makes an angle of 90 when it ejected from the bottle. The observations are also written in the slide as well. You just have a look at it. Pressure and speed of the water increases with depth of the water. We already have discussed this thing, that whenever the water pressure is here, just have a look at here. With depth, water pressure increases. As water pressure increases, so as the speed of the water increases. As the speed increases, so the lower stream cover the highest distance. With height, water pressure decreases. So pressure decrease. Point number 2, speed decreases. So it travels less distance. Okay. Now point number 2, as I have already discussed, stream of water makes 90-degree with the surface of the bottle, vessel, bottle, you can say it whatever is easy for you, container, it's your choice, as it emerges out of the holes. Okay, students, it's a very simple and easy activity. You just need to relate the point with one another. Okay. After discussing the activity, there comes a very interesting thing, that water which is kept in a container, like in this activity, water is kept in a container. So we actually need to explain a very important term regarding with this, and that is actually hydrostatic pressure. What exactly the hydrostatic pressure is? A liquid pressure which increases with depth of the liquid in a container is called hydrostatic pressure. Like in our activity 7.4, we are having a container, we are having a bottle, we are having a vessel, and in that vessel, we have observed that water pressure increases like this, and it decreases in this manner when we are going upward, means when we are moving uh, in the upward direction means height. Okay, when height increases, water pressure decreases. So the hydrostatic pressure is the pressure which actually develops in a container or in a bottle in which the water is kept, and the characteristic of hydrostatic pressure is that with depth it increases. Like we have discussed earlier, at this point we are having more water pressure, that's why speed of the water is more, it covers more distance. In this point it's less, so it covers a little bit less distance as compared to the stream number this and this. Okay, the second point, it always act perpendicular to the surface. Now the previous diagram, maybe the diagram was not so much clear to you, like I'm talking about this diagram, that angle maybe was not clear to you. So from this it's more easy. Just have a look at this point, at this point, and at this point. Each stream which is ejecting from the vessel making an angle of 90 with the wall of the container or wall of the vessel. Okay, now next. At the end, I'm going to actually review these points, which are actually a water pressure. Dear students, today we have discussed about this thing that the water pressure actually depends upon height of the water. If the water is located at a certain height in a container or in a vessel, then inside the container, there is a very high pressure developed for the liquid or the water. So the point how we are able to understand that better whether the water pressure is less or more, it is if the speed of the water is more, then on a certain space we can say that water pressure is more. There is a very interesting thing which is also given in your book, and I want to discuss that thing as well, that water pressure increases with depth are having the very practical examples in our daily life as well. The people, the students who are swimmer, they must know this thing, that it is more easy to swim at the surface rather than deep down the sea or at the bottom. Water pressure increases with the depth. The people or the students who are actually the swimmer, they experience more water pressure on them when they are moving downwards. The interesting fact is that water pressure increases 10,000 pascals if you are going just simply 1 meter down. So the people who are divers or the swimmers, they experience a high pressure on their eardrums. Okay, so water pressure increases with depth, and as long as you are moving away from the depth, so it decreases. Last point, hydrostatic pressure. We have discussed this thing, the water which is kept or closed in a container, then inside the container, the water pressure which develops, it increases with the depth, is known as a hydrostatic pressure. And most of the time that hydrostatic pressure acts like in such a way that each stream or the water makes an angle of 90 with the wall of the container. Okay, dear students, today's topic is interesting yet very easy. You can relate this by quoting and recalling a few examples from your daily life as well. That is all for today's lecture. The assignment for this question is separately given. Kindly you have a look on it, do your task, and again, if there is any query, if there is any question regarding the topic, you can ask. Thank you so much. That is all for today. Take care of yourselves. Allah Hafiz.